Okay, let's get started with the second panel this afternoon. We're still connecting change in the Arctic to global processes, and we're going to start this panel with Vladimir Romanovsky talking about carbon storage and permafrost.
Thank you. Yeah, finally we're getting to terrestrial stuff, right? I feel in a very kind of deep minority here in this audience. So what I will try to show just in a few slides that changes in permafrost are have not only local and regional consequences, but global as well. And the first thing which was help us to kind of convince scientific community that changes in permafrost can have these global consequences was the work which started in 90s, but made some good products in 2000s. And one of these products was the map of carbon in soils and permafrost regions. And this map was first developed, this version is actually updated version 2014, but the first map and paper was published about 2008. Charles Tornakai was the first author. And based on this synthesis of the data, available data, it was shown that in permafrost regions, in soils, amount of carbon total amount of carbon is about twice more than it is now in the atmosphere. So this first kind of big breakthrough for permafrost community developed this interest into permafrost, and as a result, there's many work was start to develop, and one of the very useful and very helpful way to do it was this establishment of this permafrost carbon network with Ted Schur and Dave McGuire as a PIs, which really brought this permafrost and carbon and ecological scientist community together and developed several very good synthesis papers devoted to exactly to this question. So how permafrost change can impact this global content of greenhouse gases in the global atmosphere. And as a result, well, the question, of course, here, how quickly this, the question is that what is the magnitude, the timing, and form of this permafrost carbon? It could be released into the atmosphere, and there are several sub-questions, of course. And the very first question is, well, how soon permafrost will be thawing? How soon permafrost degradation will be large enough to really produce this amount of greenhouse gases, which will be noticeable compared to other sources. And to look at the rate of thawing of permafrost, well, just as an example, I'm showing here the data from our network of our permafrost boreholes in Alaska, but a very similar picture is in the entire northern hemisphere. It's very, very typical kind of situation where we have very significant increase in permafrost temperatures, especially in the colder permafrost. And if you look carefully here, so for example, Dead Horse, it's a site, one of the northernmost sites, our site in Alaska. The warming of permafrost temperature at 20-meter depth is about 3 degrees Celsius for the last 30 years, 40 years. So we have already 3 degrees warming. This continues in warmer permafrost. The trend is similar, it's warming, but very characteristic for many places in permafrost regions that warm permafrost doesn't change too much, too fast. Probably because there is some partial thawing already. So, and this is typical situation right now. So colder permafrost warming very fast, but there is still not much of this widespread permafrost thawing in the northern hemisphere. So we don't really see a lot of permafrost thawing in the northern hemisphere in the natural conditions. However, some of the permafrost has started already to thaw. So now for the future, well, I could show you some results of modeling, but well, modeling is modeling. So I'd rather just make this very straightforward. Well, maybe it's not exactly correct to do it just like simple straight line. However, so we have already about 35, 40 years of data available. So all this part is measured. So now for the same site, the northernmost site in Alaska, if we will continue the changes on permafrost at about 1 meter depth for the future with the same rate, which was observed during the last 30 years, well, we may expect that permafrost will start to thaw there by 2050. So which is probably will not happen because of several reasons, and one of them was very good discussed just in the previous panel, that there is some multi-decadal oscillations as well, and we are on the steepest kind of stage of it. However, if even permafrost will start to thaw on the North Slope not by 2050 but by 2070, it will be a very big surprise for everybody in Alaska, I think, including some engineers of Alaska Pipeline, for example. So it was again by the efforts of this network, permafrost carbon network. The review paper was published very recently in Nature, and in this paper, this probably the most interesting results, that with all uncertainty, of course, we may say that probably by the end of the century, about from 5 to 15% of recent permafrost will be thawing, and releasing, well, developing conditions where this organic matter can start to decompose and produce gases, methane, CO2, and just simple kind of projection to the amount of carbon it could be released is about 130, 160 gigaton, which is compared to other sources, natural sources, are significant. It may be similar to land change source, but compared to release of burned fossil fuels, of course, it's about 10% of it if the rate will stay the same. So the source is not that really great, but significant. So now, what is not in this report and not in this paper is, so this paper is only about terrestrial permafrost and degradation of terrestrial permafrost. However, we know that, and this is the map of permafrost in the northern hemisphere, showing that there is some waste area in Arctic shelves where subsea permafrost exists and gas hydrates. So, and this is very wild card. So it's very huge uncertainty in even amount of carbon which is sequestered in this area, and the rate of possible thawing in the next 100 or 200 years. So this is the big kind of gap in our knowledge, which is not really easy to cover because of many reasons. So the idea is that this permafrost developed during the last glacial period, where all these shelves were land developing, the same permafrost with the same amount of carbon, and now it's covered by water, seawater. Somewhere about 5,000 years ago, pretty much all these shelves were covered, and thawing of permafrost is going on since then, and releasing gases. And of course, there's much more questions than answers what is the rate of this release, what is potential effect of it, but we cannot ignore it because it could actually increase a lot our estimates of carbon released to the atmosphere from permafrost. Including some gas hydrates on the land. And this is, I don't have time to talk about it, but if there will be some questions, I will answer to that. And I want to just, it's not in the title of my presentation, but I think that global impact of changing permafrost relates not only to release of carbon, potential release of carbon from permafrost, but also impact on infrastructure. And there is many examples of local and regional impacts, but I believe there could be very significant global impact of thawing permafrost if you take into account these new developments in the north, especially for oil and gas industry and pipelines which go through the permafrost. And for example, in this case, it's a northeast part of European part of Russia. We did some modeling showing that by the end of the century, significant part of the substrate of, the basis of these pipelines will be actually, permafrost will be actively degrading. And this new pipeline, I don't know if some of you know, which was just constructed a few years ago through all permafrost zone in Russia, and it was constructed very simple way. It was actually buried into the permafrost. So we have hot pipe, this hot oil in permafrost, and we just waiting for the disaster. So any kind of interruption of this flow of oil can have some potential impact, global impact on economy. So it's actually questions of energy security and eventually national security, global security. Thank you.
Thank you. So all our next speakers coming up, is there a question for Vladimir? Okay, thank you. So our next speaker is we're returning to Greenland ice sheets, Arctic glaciers, and sea level rise. Anders Leberman.
I have to make a disclaimer. I don't know anything about Arctic glaciers, so please don't ask me. I'm more the Antarctic guy. I'm modeling the Antarctic ice sheet. But since I was one of the lead authors of the sea level chapter of the IPCC, I think I can probably talk about Greenland a little bit too. I mentioned this earlier, and that's why I want to bring it up again. This is the temperature record, the temperature projection that we saw earlier. I keep calling this now the Paris, and this is the no Paris pathway, if you like. And I just wanted to highlight these are the next 25 years. And what I meant earlier was that within the uncertainty of the climate models, we cannot really distinguish the two temperature pathways. We all know this. I just wanted to mention this again. The sea level has been increasing over the last 100 something years by about 20 centimeters. This has been mainly due to the thermal expansion of the ocean, and the next biggest contribution was the melting of glaciers worldwide, and also Arctic glaciers. More than 95% of glaciers worldwide are losing mass, and this has been the second biggest contribution in the past. The big uncertainty, however, are the ice sheets on Greenland and Antarctica. Just this is probably clear to everyone in the room, but if the Arctic sea ice melts, this has no impact on the sea level because it's already floating, right? But if Greenland melts or the glaciers melt, this adds water to the ocean and thereby to sea level rise. You can see here the record of the satellite era. This is Antarctica here, and this is Greenland. The contributions so far are really small. These are millimeters, and this is about 20 years now. But it's accelerating, and this is due to two effects. Greenland loses ice because of melting and because of ice discharge. So an enhanced ice flow into the ocean. This is again the contributions, and you can see that Greenland is the bigger of the two, the bigger contributor of the two ice sheets. the big question with respect to Antarctica, just on the side, is Antarctica is about almost 10 times as big as Greenland, so it matters what happens there too. The question now is the Greenland contribution to sea level, how it's going to evolve in the future. And for this, it's interesting to look into the past. And what you can see here is that we had an almost equal contribution from the surface melt of Greenland and from the ice discharge into the ocean. That matters because we can handle the ice melt better than the ice discharge. The ice discharge is happening mainly through three large outlet glaciers, or actually small outlet glaciers. Two are here in the south, and one is over here. And this you can see, the D is the discharge. So we have a number 70 and a number 7 here, while you have, or 21, sorry, the other one is here. While here you have rather small numbers in the D. The surface mass balance is not equally distributed. It's larger down here than in the north, but it is something that we can handle better because it is due to the atmospheric warming of the surface of Greenland. There are complications because we don't know the albedo of Greenland very well. Well, we can measure it from satellites, but we don't know how it's going to evolve under surface melting. There is a large body of literature on the darkening of the Arctic, of the Greenland surface when there's meltwater involved, because it's changing the crystal structure of the ice. But nevertheless, we think we can handle the Greenland ice melt, and we can definitely handle it better than the discharge, because this discharge is highly connected to the ocean circulation changes around Greenland. It's water, the warm ocean water, intruding or melting parts of the outlet glaciers and thereby accelerating the ice flow. There's a further complication related to the surface melt, because the surface melt water is going down inside the ice sheet, and there was some discussion for almost a decade whether this is going to lead to a lubrication of the lubrication of the ice sheet on the ground, and thereby an increased discharge. This was then thought not to be the case for a while, and now it's back on the table. So we think now that a significant acceleration of the ice sheet is going to, or the discharge is going to be happening in the future due to this lubrication. So let me show you the projections. These are now for the RCP 8.5 here, which we are not interested in at the moment. The one we are interested in is the 2.6 here, which gives you 4 centimeters of sea level contribution only from Greenland. And just remember, 20 centimeters we had in the last 100 years, and this is and Greenland has practically not contributed to this in the past, and we're expecting a significant acceleration in the future, even under the 2.6 scenario. Now, what is important is that sea level doesn't stop in the 21st century. You can see this here from the different contributions. This is thermal expansion, projections into the future, mountain glaciers, Greenland's solid ice discharge. These are the icebergs, and this is the surface mass balance. You can see they're all curving up, and they won't stop in the year 2100. This is important to mention because it is a very special feature of the sea level impact of global warming, and that is why we have to also consider what we call sea level commitment, the future commitment of sea level that we already put into the system and don't observe yet for different levels of warming. And this is surprisingly a very simple relation, at least that's the current state of knowledge, but it's also a shocking number, because for every degree of warming we get a sea level rise of 2.5, say, meters of sea level rise. And that was one of the motivations in Paris to have a 1.5 degrees target as opposed to a 2 degrees target, simply because the small island states made increased the pressure, saying that you are taking away our national identity, our You're not just threatening our coastlines, you're threatening our land. Now, as you can see here, that 1.5 and 2 degrees doesn't really matter for the small island states. But what I also want to emphasize that at 2 degrees of warming, we'll get 5 meters of sea level rise eventually, and paleo records indicate that this might be even a lower estimate. So the paleo records are 5 plus actually, and that is something against which you'll have a hard time protecting New York. I'm just saying. Calcutta, Hong Kong, Tokyo, Ho Chi Minh City, if you care for that. And Greenland has a special role in this because Greenland has a threshold behavior. Once you have passed a certain threshold, Greenland will melt completely. And that's because of the surface elevation feedback. I call it the surface elevation feedback. The atmosphere, the Greenland ice sheet is 3 kilometers high, and the atmosphere up there is much colder than at the ground. So if you melt a little bit of this ice, you bring it into a warmer atmosphere, and at a certain stage, at a certain warming level, it'll simply not be self-sustained anymore, but it'll decay all the way. Now this happens increasingly slow the closer you are to the threshold. That is why you don't see the threshold that you see here, you don't see it in this graph here. That is because this graph is for the sea level contribution in 2,000 years, which is a long time into the future, and this is for the next 10,000 years. I'm just saying that sea level is something we start now. Sea level rise is something we start now, and for any practical purposes, it won't stop. All we can still manage, or all we can determine, is that the rate of sea level rise that we are imposing onto our societies. And I think that's already it. Thanks.
Questions while we're waiting for our next speaker? Yes, please. Microphone, please.
Thanks for the presentation. I wanted to ask just a couple of quick clarifying questions. The sea level rise commitment of 2.3 to 2.5 meters, you said that was over the next 2,000 years? And that includes Greenland, the effects of Greenland and Antarctica and other glaciers?
Yes, that's it. And the 2,000 years is kind of an upper limit. So in 2,000 years, we are certain this will have occurred. It's very likely that it's going to occur faster. And I know everyone is shutting down at 2,000 years. I know that, but.
And you said you mentioned the threshold for Greenland. Is that what I remember seeing? 1.6 degrees. Is that still?
That's the current estimate. I think this is the best estimate. There are higher numbers, but these all assume that you only have passed the threshold once you turn the entire surface of Greenland into a net melting area, which doesn't have to be the case. It's enough if you only have a net melting area in the south, because eventually all the ice is going to flow into the south anyway, and then you lose it.
Okay, we're now going to turn the discussion to security and hear from David Titley.
Thanks very much. Here we go. So this will have very little of the hardcore physical science in it. That's already being covered, I think, very well by many other speakers. I'm not going to try to repeat what you've already heard. I will talk a little bit about the security. And the first part, and Mary Beth kind of talked about this, I think, earlier today, but I think especially at a ministerial meeting, it's really important for us to remember, I think we all know it, but just to remember that when we say Arctic, there's a lot of different images in different people's minds of what the Arctic is. So on the left is Barrow, on the right is Tromsø, almost the same latitude. I would take my wife for a nice winter vacation in Tromsø. I'm not so sure about Barrow. It's a very different world there. And then you go up to 80 degrees north, or almost 80 north, and you have Svalbard. And again, it's much more developed than anything we have, certainly at those latitudes, because all we have is, well, ice sometimes. So where you are in the Arctic and where you've come from, I think really can shape your perception. So we say Arctic, what is it that we're really talking about? Not a security question exclusively, but I think especially as you prepare for a ministerial and you're sitting around with other people, just to remember that. I put up just a short slide. We're not going to go through this in the time available, but really to show that for the U.S. Navy that I can talk to most comfortably, the Arctic interest is episodic, and it's episodic when it is in the interest of that organization to be interested. So I think, again, as we think about what we're doing in framing, how do we make it in their interest, whomever they is, policymakers, Congress, other stakeholders, not so much our interest of science. There's lots of cool science to do, we know that, but our job is to explain why they should take some bandwidth and devote it to the Arctic. So yeah, the Navy's been interested, again, when it suits them, either because the Japanese took one of our islands, constructing the dew line, the Cold War of the 70s and 80s, and now as the ice is retreating and the changes we have. We've seen this many times. I just put this up. This is 1990 on the left and 2000 on the right. This is winter, not summer. And if you look closely, the coverage is not all that much different. But what is hugely different is that thickness of the ice. We've lost the volume. I use this a lot of places to show that the climate is not changing in some theoretical future way, but it's happened. It's already changed, and that change will continue. Lots of considerations. You've probably heard these in different places at different times, but really these have not changed. And since I've been working Arctic issues in 6 or 7, 8 years now, we still have very poor charts of the Arctic. It's only about 5 or 6% is being charted to modern standards. What do I mean by that? Multi-beam sonar and a GPS. The infrastructure for all of us, many of us have been up in the Arctic, we know it's very, very limited. When I was in the Navy, I was saying, imagine you had to patrol the United States and you have, one very small base like in the Channel Islands, and that's all you have. There's just not a lot there. The operating environment in some ways may be getting even harsher. There's more variability. Was mentioned this morning about as the ice melts, of course, you have longer sea fetch, you can have greater sea waves. That can lead to icing on surface ships. So in some ways, the operating characteristics are becoming more challenging, not less. Security concerns certainly abound. Lots in the press about what Russia is and is not doing. They say they are building search and rescue bases along the northern sea route. I don't think we have too many search and rescue bases with 150-mile surface-to-air missile batteries, but that's just us. One thing though, if you look at, this is Russia down here at the bottom, and it's almost as if you were standing at the North Pole looking southward with no ice. And when I look at what the Russians are doing there, they're kind of doing to their northern sea route and that coast what we have done in our country to the Gulf of Mexico. Lots of resources for them, 3 rivers each the size and the scope of the Mississippi flowing in. I mean, it is rational for a country to want to develop their resources, and they are really the Arctic nation. 21% or so of their GDP comes there. One other thing, for the Russians, they have for centuries relied on that ice to be that de facto northern frontier and protection. And that ice is gone, and a colleague of mine in Norway often says that, it is opening the 5th ocean of Europe's northern frontier. So some of the actions we see with the Russians building up defenses there, that ice isn't there. So it's kind of a trust but verify, but I personally don't get too excited about what the Russians are doing, although it needs to be watched. Transportation, we've talked about this a fair amount already this morning. This comes out of what the U.S. Navy's Arctic Roadmap. It's out on the internet, anybody can access it. And that green line is kind of that transpolar route. So the Navy is on record as saying in about a decade from now, they think that would be viable for about 2 weeks. Now, as we had in the discussion before lunchtime, 2 weeks will probably attract, honestly, very little shipping. The shippers tell me they need at least more like 2 months than 2 weeks, and they need it to be, no kidding, guaranteed. We talked about the challenges with the northern sea route, or excuse me, the Northwest Passage. Both Northwest Passage and the Northern Sea Route, in addition to the technical issues of navigation, has some governance issues. Both Canada and Russia claim part of those respectively as internal waters. That is not universally accepted, and that's another issue that sometimes comes up, although certainly for the Northwest Passage, it really isn't something that any country is really pushing right now. The DoD, like many other organizations, does have an Arctic strategy. The thing that makes me happy when I read almost any country's organization strategies is two of the 3 words, safe, stable, and secure, are in there. I think that gives a lot of commonality and potential commonality. I'm just going to talk for a second before I close here about a piece of the Arctic that we in the US don't always think about, but I'll bet some people here, maybe many, have been to. This is Svalbard. It is not episode 2 of Star Wars or anything like that, but one of the unique things about Svalbard is being so far north, almost 80 degrees north, is they have access to every single polar orbit of every polar orbiting satellite. I had to explain that on a bus going to this site to a bunch of history and political science majors. That was sort of fun, and trying to explain to them why you couldn't just move this to Singapore. That was interesting. So you have really the high ground of space is potentially, for polar orbiters at least, can be controlled from Svalbard. Fairbanks is pretty good. Svalbard is better. And Svalbard is really kind of a place where we see this intersection between science and some of the security. And to my knowledge, the US does not have a permanent research station on Svalbard. We are signatories to the Treaty of Svalbard, and Svalbard the Norwegians feel very strongly about it, but other countries have a presence there, including the Russians, including the Chinese, and many others. The Norwegians sometimes get a little nervous about Svalbard, and it's a place the Russians push. So one other risk that we've kind of talked about, it's really this linkage of the sea level. So when we think about sea level, we don't always think, except maybe in erosion and moving coastal communities, what we have to do. But I was in a meeting in Bergen, Norway on a security issue, come out on a Saturday morning, and this was kind of not even a particularly high tide. So countries are going to have to deal with multiple climate issues at once, and that includes the Arctic countries. So they're going to have a domestic sea level rise issue in addition to the security issues in Norway here. Cooperation is good. There is something called the Arctic Security Forces Roundtable. Happy to talk about it more after in Q&A or offline. What to do? Lots of people have written things. These are a couple documents I've worked on with others here. Probably nothing too exciting, but the commitments and engagement, the monitoring the Arctic in both a shipping sense, in a people sense, but in a scientific sense. I think we can find common interest between the security community and the science community on that. And with that, I'm done. Thank you.
Very good.
Thanks very much to everyone. I have a question for Admiral Titley. Something I sometimes think about and wonder about is if Russia were to be successful in its claim to a majority of the central Arctic Ocean, would they make a claim that it falls within Article 234 of the UN Convention on the Law of the Sea, the so-called Arctic exception, meaning that they would be able to enforce the non-discriminatory rules about where you can go for ostensibly for environmental protections. But because the claim would be to the sea, as you know, to the seabed as opposed to the pelagic zone, I wonder whether such a claim would hold water, so to speak, and whether the Navy is concerned about that.
Thanks for the question. I am not a law of the sea expert to that degree. I know a couple people who are, who could really answer this, but everything I've seen and talking to folks who really do study both this issue and Russian security, I have not heard anybody who looks at Russia make that particular claim. Now, certainly they have, I think everybody here probably knows this so-called Article 76 claim of extensive claim to the seabed and whatever is beneath that, minerals, etc. And of course they have the North Pole, and they'll eventually this will all be adjudicated. But I have not seen Russia push some extraterritorial claim that says, well, since we have the seabed, 234 now applies way out. I think they do use 234 like the Canadians use it in the Northern Sea Route. But what we have seen is the Russians actually act more like a normal country in the Arctic than they do in many other places. So, my personal opinion is the U.S. should reciprocate that when we can. Science, we do. Coast Guard, we do. Unfortunately, the Russians have not been invited to the Security Forces Roundtable. I personally would like to see that change, but I know it's part of larger issues. But short answer is we have seen no evidence, at least I haven't, that the Russians might try to make that type of claim.
Doug, did you have a question? And then I have Rafe and Robin and Vera.
Just very quickly, concerning the Navy's role in potential search and rescue, is that an area of ongoing activity?
So Navy's role in search and rescue, if there are naval assets up in the Arctic and there was a search and rescue event, the Navy would very likely be called on to assist. The U.S. Navy and actually most navies do that in any ocean, so we wouldn't treat it any differently. The difference is there are very few naval assets that would be in a position to assist, but right now there are very few Coast Guard assets. And this is, as we've talked about the shipping and the insurance, one of the issues are, it's like, okay, the Arctic Council, we have a nice search and rescue agreement, but unless there are assets that can actually go out and get somebody, you're not going to get rescued with an agreement. So you'll get rescued with a ship and a Coast Guardsman. So yes, but if there is a naval vessel there and there was a search and rescue, then the Navy absolutely participates in that.
Rafe?
Thank you. It's on? My question is, Vladimir, in working on up this framework on the Arctic, one of the central issues has become, I'll put it this way, can we allow permafrost to thaw? Isn't that too big a risk? Because if you let it thaw and it has double the carbon content of the atmosphere, we have these estimates, any stable concentration will then, assuming the thaw works, and you then get an added increment of carbon dioxide. So, but one of the things that doesn't get discussed in a policy-making context is the thing you identified, which is risk. The risk in the seabed, the risk of hydrates under the land, and the risk of, if I understand this correctly, of additional release from places like beneath lakes. I don't understand that one. But so I wanted to ask you to expand a little more on this question of additional risk beyond what's been identified in that review paper.
Thank you. I think it was a couple years ago, maybe a couple years ago or more, it was a report, I think USGS, about hydrates and potential risk of release. And I think the conclusion was risk is high, but uncertainty is so high that you cannot estimate the risk. So that's the problem. So in terms of risk, it's huge. But what is the probability of anything unusual happen? Well, we cannot estimate it. So, but it's real. It's real.
Yeah. So the way it doesn't get characterized is, I mean, if we're thinking about this, is It's a hard one, but can we afford to allow that risk? Can we afford to find out if it goes wrong? Then you have an additional potential very large release of a methane or whatever, carbon dioxide, but at the point at which it goes, you don't have nothing you can do about it. So it's sort of a policy question, a risk management question, to know a lot more about that than we do today. But in fact, you'd really have to make a decision about it today, simply knowing that there was a risk.
Well, yes, I believe the risk is high. However, to make this uncertainty smaller, it will be necessary to invest, pretty significant amount of money, because it's really why uncertainty is big, because we don't know too much about this. That's the problem. So to decrease uncertainty even a little bit, it will be necessary to invest significant amount of money. However, there is some way to do it. I mean, it's scientifically it's all possible, but practically it's very difficult, because it's so expensive to get information what will be necessary to decrease the uncertainty.
Can we learn something from the paleo record on this? Because when if we're dealing with a 1.52 degrees warming world, there have been times in the past where we were close to this. And with respect to permafrost, I remember something. There was a paper or whatever, 2004. I don't know.
Well, yeah, it's possible, of course, but again, paleo, especially in such a long-term paleo, uncertainty is also very big. And the arguments were that there was no, during the previous interglacial, there were arguably global temperature was higher than now by 1 or 2 degrees Celsius. It was no evidence that it was some big release of methane from subsea permafrost, which also exists during that time. So here, the present day interglacial is very different from it was the previous one. The previous one was high peak in the beginning, and then stable and kind of constant cooling. So what we have now, it's warming, maybe not as much as that peak during the previous interglacial, but stable for 10,000 years. And now with additional warming during the later stage of interglacial can change situation completely. So it will be very different from it was in during interglacial period.
I just want to add that, in terms of understanding the potential for methane releases from northern soils, there's Search is planning an international workshop in early 2017 to really focus on bringing together the permafrost community, people working on this from the subsea perspective and from the atmospheric perspective, to try and reconcile the different accountings that happen in those three communities. And let's see, I think, Robin, I think you were next.
So sea level rise isn't uniform around the globe, and I think it's really important to recognize that, because you just look at what's happening on the southeast coast of the United States, where you have an increase in nuisance flooding. And so my point during my presentation about having community-based monitoring is critical for communities to understand how sea level rise is going to affect the place where they live, and also critical for policymakers, because you can't use these uncertain projections about future possibility of sea level rise impacts in order to make decisions today about future adaptation.
The point is well taken. I proposed already a few years ago that there should be some kind of engineering kind of group that is financed internationally by someone that you can hire to compute your specific regional sea level rise. I don't know whether that's a good thing or not, but I know that a lot of communities can't really afford this, and it's also not something that scientific community can can provide, because it's just not a scientific issue anymore. There are so many different aspects to regional sea level rise that it's not, you can't write a PhD thesis on it, simply.
So in the South Pacific, a colleague of mine has figured out how to get remote sea level rise sensing equipment that's really inexpensive into these island communities because of the impact of sea level rise on their ability to stay there. And so it is possible. I think we just need to be a more innovative of how to do this community-based monitoring.
Well, but then you have it, you know, then you observe it. That's not a projection, right? You'll have a hard time to figure out how much Greenland contributes to your local sea level by this method. So it's not so simple.
Vera?
Good afternoon, Vera Metcalf with I live in Nome, Alaska. This is for Admiral Titley. Thank you for your presentation. Bering Strait is considered an international strait, and it's about 30 miles from Gamble on St. Lawrence Island and about 3 miles from Little Diomede. And many of our subsistence hunters are out there in the environment, always, you know, noticing the changes, and I'm sure they see unusual things going on as they're out in the waters most of the time. My question to you is, what are some of the risks increasing because we're so close to Russia that we should be aware of living in many of the coastal communities?
I think, you know, with Russia, it's always hard to go figure them out, because, you know, if you lived in Ukraine or Crimea probably a few years ago, you'd say, yes, it's a lot of noise, it's all internal consumption, but they really wouldn't do anything. And of course they did. Having said that, you know, when you listen to either Admiral Papp, I mean, everything I see, which is just really open source nowadays, the Russians are not really building an offensive capability. When I talk to our senior leadership in the U.S. Coast Guard, they tell me they have a very good working relationship with the federal FSB, the Federal Security Border Guards of the Russian Federation. As I mentioned, the Russians seem to act more like a normal country in the Arctic than in other places. That doesn't mean that there won't be disagreements from time to time, either, let's say, Russia-US across the Bering Strait, or Russia-Norway on the other side. But it seems like they've been able to mostly work them out with really minimal conflict or minimal potential for conflict. So I think it's a place where the U.S. needs to engage in a constructive fashion. It doesn't mean we should condone Russian actions, let's say in Ukraine or Crimea or other places where they're misbehaving. But in a business-like sense, we should have engagement with them in the Arctic. It's in our interest. It's in the Native Alaskans' interest, I think, to have that engagement. So I see that's something that, you know, we should pay attention to. When I talk to Alaskans, they tell me what they're looking for U.S. presence is simply U.S. flagged presence, be that Coast Guard, Navy, NOAA ships. But just, it sort of lets the rest of the world know. It lets the Russian Federation know that we know this is America, and we're here. And I think that's kind of where we need to be. We don't need to be or should be, want to be provocative or anything, but it should be a business-like relationship, but it has to have some sort of communication. But from what I've seen, I think that's reasonably well managed right now.
I have a question here, and then...
Okay, thanks. Andreas, you are claiming that 1.6 degree is a tipping point for Greenland ice sheet. So my question is there a tipping point for Arctic, Antarctic ice cover in general? And if there is one, how far are we from that? Because it appears to me that even if we adhere to the Paris Agreement, we are going to enter a new mode of behavior, because we are going to lose a substantial amount of ice extent there.
Yes, well, In Antarctica, there are a number of tipping points, if you like, because it depends on the different, there are different outlet glaciers that can tip. Antarctica won't melt from the surface, it'll always melt from the ocean side because it's around the South Pole and it's very cold. At the moment, the scientific community is of the opinion that the Western Arctic ice sheet has been tipped already. There were 3 papers coming out in May 2014 that all stated that the Amundsen Sea sector of the Western Arctic ice sheet has been disintegrated. We then used our ice sheet model, which was, by the way, developed in Alaska, in Fairbanks, to compute what this will mean with respect to sea level rise on the long term, and on the multi-millennial time scale, it'll be 3.5 meters of sea level rise only from this region. There are other regions in Wilkes, for example, based in Eastern Arctica that can also tip, that haven't tipped yet. Now, this is all a discussion. It's all, it's still in the scientific realm. So, but there are different tipping points, and they're very difficult to identify, even though it's ice, and it's generally easier with ice than, for example, with the Atlantic overturning circulation, because it has a melting point. But we don't expect rapid jumps in the sea level, really, because even if these tipping points are initiated and they're passed, for example, with Greenland, there is a tipping point in the sense that once you are beyond this temperature increase, beyond the 1.5 or 1.6 degrees, you cannot really sustain a Greenland ice sheet anymore. But the closer you are to this tipping point, even on the bad side, the longer it takes for the ice sheet to vanish, which is why you don't see steps, right?
Can I ask a follow-up?
Yeah, hang on one second, go ahead.
So just in a hypothetical world, if let's say you get to that tipping point, if you somehow took the Earth's temperature back below that tipping point, does that stop the ice, or once it goes, it's really going?
No, this is important for Greenland. You have it depends on how much ice you lose. Once you have lost enough for the surface to be so low that it's too warm, you lose it all. But you have actually centuries to go back for Greenland. For Antarctica, it's different, because once you have crossed the tipping, that you have actually melted away the ice plug around the coast, and then you lose it all even if you go back with the temperature.
Yeah, my question is just around the tundra, the permafrost, and the estimates of carbon loss. I didn't really understand the methodologies and whether those were modeled losses or measured losses, and if there were measured losses, does the estimate take into account, or does it through modeling take into account the albedo changes and the increased warming associated with that, and also back to the albedo changes that are happening at the ice at the same time, so that you might get these feedbacks going that could actually accelerate permafrost loss? And what does that mean for that sort of connected land-sea interface?
Thank you. It's a very good question. Actually, it's a question about this Earth system models, really, because you can only have some trust in results of models if this model will include all these mechanisms, what you just mentioned, and many, many more. Unfortunately, there are many models, that climate models, even called Earth system models, which include permafrost in those models. But in reality, the representation of permafrost in these models is very, very poor, because it's very difficult. It's different, a different scale of the processes. All these estimates, they were made mostly on not coupled models with permafrost, but separately. So if you take a projection for climate, then you can estimate how much of permafrost will thaw by 2010, for example. And for different projections of climate, you will have different projections of degradation or disappearance of permafrost. Then you multiply by volume and concentration of carbon, and then there is some other process should be taken into account, how long it will take to convert this matter into CO2, if it will be some portion in CO2, some portion in methane. So it's pretty complicated thing, and there is no model exist by now which it will take everything together, which will be ideal. In this case, you can have all these positive and negative feedbacks in one model. So it's not there. So all these estimates, they're very preliminary, based on decoupled models, and that's why uncertainty is so big.
And just a follow-up then, do you have a sense, just of, given how well you know the system, of how big those feedbacks could be? Just if you were to start running experiments, what would your hypothesis be?
How what? I'm sorry?
How big could those feedbacks be on the carbon loss from the tundra, given the...
Well, you see that it's still not a huge amount. I mean, it's a big amount, but not compared to release of burned fuel carbon. It's not that big, 10%. So the addition to warming and global warming, it probably will be just tenths of a degree. So it's nothing catastrophic, except for this uncertainty with hydrates and subsea permafrost. That could be much more serious.
You said that there was something on the slide that said like 100 to 130 gigatons, right, in carbon. So 10 gigatons is what we emit at the moment every year. So then you have...
Kathleen.
This is related to the last question. Vladimir, you showed a slide on of the vulnerable fraction of permafrost in the Arctic, and I think your slide said 5 to 15% is vulnerable. Can you just clarify
by the end
that?
of the century, yeah.
By 2100.
By 2100.
Under current warming trends with the Paris Agreement?
At different scenarios.
Right, which is why you have the range.
That's why it's raised, 5 to 15. And again, it's very big uncertainty in even these numbers, because like I just answered, it's based not on coupled models, so it may not take into account some, but well, this is not good estimate, but it's the best at this point. Yeah.
And yet that slide also said that, I think it said that 10% of the known carbon stored in permafrost could be released. Did I get that right?
I'm sorry?
10% on that same slide, you had a figure that 10% of known carbon stored in permafrost could be released under that scenario?
By the 2100.
Okay.
Yes.
Okay. And then, sorry, Anders, can I ask you a clarifying question on this Greenland ice sheet? I've often heard that, and then maybe this is incorrect, just through the media reporting on Greenland, that after 1.6 degrees Celsius, we have unstoppable melting. So that's actually, based on what you said, it could be stoppable depending on how much ice is still left.
It's unstoppable if we keep this temperature, but you can go back and then it's stopped.
And how much ice do you need to have to stop it?
I don't recall the numbers exactly, but it's you need a significant percentage of the total ice sheet to be gone. So I'd say more than 10%, rather in the direction of like 25% of the ice sheet having melted altogether until it gets unstoppable. It depends also on the temperature that you're on. But I think if you lose something like this, then the ice sheet is so much lowered that you can't stop it anymore. But that takes a long time. Greenland has enough ice to raise sea level globally 7 by 7 meters, so 10% would be 70 centimeters, and that takes a number of centuries. Well, 2.
Rafe? Rafe, and then you.
Okay. I want to just fill in a gap because Xander said, don't ask me about Arctic glaciers. So I'll act as though somebody asked me, because we did a lot of work on this. Remember when the president went to Anchorage, he talked in his speech actually about Alaskan glaciers And as I understand it, there are two big systems in the Arctic, the Alaskan and the Canadian. The rest, they're all going. And the problem is that the Alaskan and Canadian glaciers are big enough to contribute significantly to sea level rise. I think the total in mountain glaciers is like 2 feet, but they go fast. And
No, 2 feet is all of the glaciers on the planet.
right, but
Okay.
the biggest portion of them are the Alaskan and the Canadian. And no?
I'm sorry, that cannot be. There's Patagonia and there's Himalaya. There's
No.
bigger.
Well, anyway, we could
Sorry,
determine
I'm
that
just-
later.
okay.
But they are significant source of sea level rise, and I believe that the Alaskan and Canadians are important.
I have two questions. One to Vladimir about.
Could you hold the mic closer, please?
Yeah, I have two questions. One to Vladimir concerning gas hydrates on the continental shelf. What is the latest on that? There are basically three risks. Okay, one is release of greenhouse gases to the atmosphere. Is this still discussed in the community that that a significant amount of greenhouse gases can escape into the atmosphere? Second risk, if not, acidification may be a problem in that region, ocean acidification. And the third one is landsliding, right? And excitation of tsunamis, well, whatever. Can you comment on this? And the second one is to Anders about regional climate change. So we are talking about Greenland, Antarctica, and so on, and this also affects gravitational attraction. Okay, and the losers are the tropical island states. Okay, maybe you can also comment on that.
I didn't catch the question. Sorry.
Yeah, maybe I can try
The
to
gravitational-
first question, and then you'll start.
Yeah.
I'm not completely sure that I understood exactly, but so the question about amount of methane released from Arctic shelves, and there are several opinions. Some say there's lots of it, some it's maybe not. That's the question, or?
Yeah, right. Whether this is still, discussed in the community that a lot of methane could escape into the atmosphere, or is most converted into CO2 in the ocean.
CO2 in the ocean. Okay, good. Well, there is some work actually done on this direction. Somebody from our group can answer better than I can, but. I think it depends how this methane released from the floor delivered to the surface. So if it's delivered as a bubbles, then it will be pretty, significant amount of methane will be delivered to the atmosphere. If it goes through the diffusion, then probably not much. So
is this a follow-up?
Yes, the oxidation rate of methane
I had a second
in
one,
these
yeah.
cold waters is about 2 years. So,
Thank you.
You ask about the impact on the small island states of this sea level commitment?
Right. So I'm referring to the gravitational attraction. If Greenland melts, if Antarctica or portions of Antarctica melt, right, we have changes in gravitational attraction, and the water accumulates in the tropics. Okay, and if significant amounts of the ice sheets disappear, this could become a major problem. And is this included in these numbers of 1.5 degrees and so on?
I just cannot hear you.
It's really hard to hear. Could you hold that a lot closer and
Yeah, but I can't hold it closer than I do.
Okay.
I'm almost biting into it.
I'm sorry.
Or maybe I can use another
I
microphone.
don't want to annoy you. I just don't get it. Oh, the fingerprint. All right.
Yeah, the gravity. That's better. Okay, the gravitational attraction. Okay, because the tropics are the losers in that
Exactly.
game.
Well, let's just say the small island states are doomed, and well, you can put it in a different way. You can say that we put an expiration date on these nations, very simply, and we don't really know the date, but we know they are going to be in trouble. And the fingerprint, as you said, is against them. The fingerprint is the following. At the moment, the big ice sheets are are pulling the water masses of the ocean towards themselves because of their own gravity. Now, if you lose ice in Greenland, the southern hemisphere, the sea level will increase. In the southern hemisphere, the sea level will increase more than in the northern hemisphere. If you lose it in Antarctica, the northern hemisphere comes up more than in the southern hemisphere. But the tropics is always the problem. They always lose. They lose whether you lose it in the north or in the south. You're right. So there's a belt of sea level, enhanced sea level increase in the tropics.
Scott. Thanks. My question is about effect of permafrost subsidence on inland non-coastal infrastructure, so putting aside coastal erosion for the moment. My understanding is that a lot of the destruction of infrastructure, particularly in Russia, has as much to do with poor building codes, or at least building codes that did not take into account the effect of permafrost subsidence, as it does with climate change, and possibly more so. So first question is it fair to treat that infrastructure as essentially lost, given that it was never built to withstand permafrost degradation in the first place? And secondly, as more of a curious follow-up, given that it was the ESPO pipeline that you showed, the East Siberian Pacific Ocean pipeline, or given that that's more recent, I'm just a bit surprised that they wouldn't have had the foresight to realize that this was a potential pitfall, and if you have any insight as to why that's in danger, given that it's a more recent bit of infrastructure.
Okay. First question. That's true that most of the problems or failure of the civil infrastructure, like houses built on permafrost, because of not proper using them. And one of the examples is, one of the section was because of hot water was leaking into the basement for whole winter. So, and with problems with local, financial support of these local communities. For example, there was special service, permafrost service in Russian big cities, which continuously monitor permafrost state under buildings. Of course, in the early 90s, this service disappeared, and now everybody on their own. So the big problem is because of just not enough money to properly explode the existing infrastructure. In commercial infrastructure, especially in oil and gas, of course, there's more money, and they can afford to do it. But nevertheless, there's some kind of unpublished data that about 95% of all failure of this of the infrastructure, especially in the pipelines, happening because of changes in permafrost. Now, how it's related to warming? All this structure was designed and built by codes, but they include in this design temperature, for example, -4 degrees Celsius, and now it's -2 or -1.5. So simply the recent situation with permafrost is not right for the design. So it's combination of impact of infrastructure itself and climate change. So for the second one, for this pipeline, well, unfortunately, lots of things happening in Russia in a way that let's do it fast, get the money, and then what happened, well, we don't care about it, unfortunately. And for example, for this pipeline, it was actually some pretty significant amount of money was put into assessment, like environmental assessment, but before this assessment was completed, the pipeline was already, in the process of building. So again, theoretically, everything was supposed to be done right. Practically, they wouldn't care about it. So there is some potential of big disaster there. But well, we'll see.
It strikes me that this last example is just kind of good evidence that understanding the problems well is part of the problem, but actually entertaining the solutions has a lot of dimensions to it beyond the understanding, including the socio-economic system. So with that, I'd ask you to thank our speakers again.